Download this code from codegive.com, link in the description below. Deep copying bfloat16 arrays, pitfalls and solutions. The bfloat16, brain floating point 16, data type is a 16-bit floating point format used increasingly in machine learning for its memory efficiency and faster processing speeds compared to float32. However, deep copying bfloat16 arrays can lead to unexpected behavior if not handled correctly. This tutorial dives deep into the challenges and provides effective solutions. Understanding the problem ***. The core issue lies in how Python's deepcopy function, from the copy module, handles custom numpy data types like bfloat16. Deepcopy aims to create an entirely independent copy of an object, including its internal data. However, the process may fail to correctly replicate the underlying bfloat16 type information, leading to a conversion to a different type, often float32 or float64. This conversion can significantly alter the values stored, especially when dealing with the limited precision of bfloat16. Illustrative code example ***. Let's demonstrate the problem with a simple example. Running this code often shows that the deep copy results in an array with a different type than bfloat16, leading to np.array_equal, returning false and showing numerical differences. The deep copy might show float32 or float64 as the resulting type. Why does this happen? The copy.deepcopy function uses a recursive approach. It tries to recreate the object's structure and copy the data. However, np.bfloat16 is a relatively new and less commonly handled type, and the deep copy might not have fully optimized handling for it. The internal workings may trigger a default conversion to a more broadly supported type. Solutions ***. 1. Using copy.copy, shallow copy for numpy arrays. For numpy arrays, a shallow copy often suffices because it only copies the array's data pointer, not the data itself. Since numpy arrays store the data contiguously in memory, this is very efficient and avoids the type issues. This approach is better in the context of numpy where data is stored contiguously. 2. Manual copying with a type ***. The most reliable method is to manually create a copy with the explicit type method, ensuring that the target type is bfloat16. 3. Using np.copy ***. numpy provides its own copy function, which is generally more efficient for numpy arrays and handles data types better than copy.deepcopy. Recommendation ***. For most scenarios involving numpy arrays and bfloat16, using np.copy, or a shallow copy, copy.copy, is recommended. These methods are efficient and preserve the bfloat16 type. Only resort to manual copying with a type, if you have very specific needs or encounter unusual situations. Avoid copy.deepcopy, unless absolutely necessary for complex nested structures where you truly need an independent copy of all data. Remember to always verify the type after copying to ensure the operation was successful.